All right, so picking up where we left off, we finished off with this example about independence yesterday and all of that fun stuff. So the next thing is segmented bar chart.
Are we using the same strawberry example?
Yeah, for one more thing.
I guess I'll just use different colors, but I don't remember what colors are.
So with a segmented bar chart, okay, each bar is a whole. It's used to compare two different groups. Bars are the same height. To compare relative frequencies, which are which ones?
The ones that makes sense.
Yep. Or to compare relative frequency, not counts. All right, so I'm going to draw a little example here using our ice cream. No, too small. Good enough. All right, so I'm going to have A and B, male and female.
Are these the ones with two different colors on each? These ones are confused.
Also, you didn't come find me during fourth period.
I know, because I went to go find Miss Marshall because I left my chemistry stuff all at home, so I had to tell her that I wouldn't be able to participate, like, with what we were doing today in class. And then I just got distracted. Either I'll get it before the end of the day, or I'll just suffer and not get them.
All right, so male and female were pretty equal, I think, looking back. Yeah, they were.
Oh, is that what the chocolate one?
Yeah.
Yo.
So what I'm going to do is I'm going to actually use my little highlighter here and do it this way. So male and female were pretty equal for chocolate, or were equal, I guess. And then let's see, I think I used yellow for vanilla. So it was 17% for men, 30% for women. So something like that. About. And then strawberry was what was left over. So something you need to be aware of when you are doing a segmented bar chart like this is that you need to be aware of area and scales. Okay, that's why we want them to be the same size and basically look the same as much as possible. I realize one of mine might be a little wider than the other one, but you want them to be about the same height if you can. I mean, I'm not going to get out a ruler and check, but it's really easy. Huh?
That would be
Like, if you were like, if these aren't exactly the same exact size, you're getting 25.
Yeah. It's really easy to misrepresent data
I do crazy things.
using inaccurate graphs or scales. All right, so we're gonna do another example here that we're actually gonna write out ourselves, and then we'll go to that. Well, we'll have one more little note, and then we'll move to that worksheet. So, does everybody have this chart thing and all that? Okay, I'll wait to move that up then. So this is gonna be a survey of cars in the school parking lot, not ours, but just one, based on the origin of the car.
Like, place?
Yeah, so it's going to be USA, Europe, and Asia.
Have you ever seen one of those license plates that are like for soldiers that like go out of this country?
Yes.
I saw one of them and was freaked out. I was like, what does that even mean?
I saw a license plate. Antarctica.
We should take a picture of that.
But it was like, it was weird because it wasn't like a place license plate. Like, it was like, it was weird. It was like,
Sarah, what was the weird one that we saw?
They always
Driving home from North Carolina.
Be playing the license plate game and then find like Ontario or
Isn't it from, like,
something.
Canada?
It was from Canada.
Ontario.
And it had like, no, it was like blue. And it was just like, it was literally just blue. It was definitely from
I
Canada.
don't know what it was.
But it was blue and like had yellow writing, but it didn't tell you the place on the front part of the
Is
car.
this being recorded?
Yes.
Oh.
It's okay, we're just trying to license plate.
At least it's recording.
It's true. Wait, is that a table or a graph?
A table. So the left side is going to be car. Wow, I cannot spell.
Oh.
Stop that. Car origin.
Do we always see your hand that much, or is that just new?
Huh?
Do we always see your hand when you're writing, or like? I just
Yes,
remember
bro.
seeing it.
Well, I mean, I don't just like make it ghostly appear up there. So
Wait, how many lines do we need like in between like
3. There's 3 in here.
I need to ask that before I make the.
And then down here is going to be the total.
okay, so in total like 5. I'm tired.
And this is information that would be given to you.
What is on the very top?
Driver.
Aha.
So if it's a student or a staff member. Then we're going to have USA, European, and Asian. All right, so for students going down, it's 107, 33, and 55, with the total cars of students being 195. Staff going down 105, 12, and 47, with the total being 164.
So there's more kid costs and staff costs.
Kids.
So then we want to know, is car origin and driver type independent?
Can you explain what that means again?
Yeah, I'll go back up to, well, I was going to say I'll go back up to it, but I guess I probably shouldn't do that while everybody's writing. So basically with independence, it's, I'm going to find the exact definition here so I can, so it'll essentially tell us if they go with each other or not. Like if one affects the other.
No.
So if it's independent, they do or don't.
So it means if like staff has like 100 European calls, but they're the same. They're almost the same, so they're not independent. They are independent, right?
What?
Well, we're going to have to do, because you have to remember, there's not the same number of staff cars as there are student cars. So we're looking at the ratio for each type to driver type. So each brand of car to each driver type. And if those ratios are the same, then they're independent.
Okay.
So like with our, I'll go back up.
The chocolate one.
Independent.
So see how like these percentages were different?
Mm-hmm.
So that means that they're not independent. If it had all been like chocolate, then it would have been independent.
Okay. That makes sense.
And it'll make more sense as we do more examples too. Because like it's one of those things that like I feel like independence is kind of hard to understand until you just do a bunch of examples and then you see it. Kind of. So we're going to start with American cars. And we're going to start with students. So for students, there's 107 American cars out of the total 195. And normally when we're doing examples, I'll have y'all get your calculator out and type in and tell me what those decimals come out to be. But since this is in the notes, I've already got them worked out. So it's going to give you the decimal of 0.549 for 54.9%. For teachers then, we have 105 out of 164. That's going to give us 0.64 or 64%.
So we already know the answer that they're not independent, right? Because those two don't match.
Correct.
They
So
the exact same
the
number.
conclusion that you would need to write because of this, okay, there's a lot of things in stats you have to explain why. You can't just say not independent. You've got to tell me kind of a reason that goes with it. So
Not the same percent.
teachers are more likely to drive American cars than students. So the events are not independent. There's one other way that we can look at knowing if something is independent or not, in a sense. And so we're going to look at that. If you don't fully understand it right now, that's okay. We'll deal more with it, with this particular aspect later, but I'll go ahead and show you now kind of how that works. So our marginal distribution, and I'll give you a better definition of marginal distribution after we finish this example as well. But our marginal distribution for American cars is 107 plus 105 divided by 195 plus 164. So it's the total out of one of your rows divided by the total between the two columns. Okay, so that gives us 212 out of 359 for 0.59, which indicates a lack of independence.
What would it be if it was dependent?
Well, they would all kind of need to be equal, so I'm trying to remember exactly if it's that they have to be 50% or if it's that they all have to be like the exact same. Because this is obviously just for American. Well, so this is for American. There's obviously 3 different types, and so there's no way that the other 2 can also be 60% and add up to 100%
That
total.
is true.
So that's part of it. So that's one other way you can check. Like I said, it'll make more sense later. The official definition for marginal distribution, because I gave you kind of a rough definition up here. I just kind of said it shows category totals. There's a little bit of a better definition, more specific definition, I guess you could say.
Wait, is that the only part we're doing for this example? Or are we doing
That's all we're doing for that one. We just wanted to check independence on that.
So, since we check the independence only on the Americans, what does that mean? Like, how do we know the European and Asian aren't independent?
Because if one's not independent, none of them are.
Oh.
All we have to do is show that one of them is not.
So, like, say American was the same. Like,
If they were the same, then we would need to keep checking until we find one that's not.
and then you just say.
And then if they're all the same, we can say independent.
What about the chocolate? The chocolate was, but the other 2 aren't.
Yeah, so after we did chocolate, we went down and did the other one and showed that it's not the same.
So, we only need to test, like, we go down.
I just showed you all of them so you had it
Oh, so.
for reference.
So, say US was the same and European wasn't, we would just say it's not independent because the European one's multiple.
Mm-hmm.
Okay.
All right, so the definition for marginal distribution, and like I said, a lot of this makes a lot more sense the more examples that we do. So if it's not fully clicking now, don't stress about it. It will make sense the more examples that we do. The frequency distribution. Of one of the variables from the margin of a contingency table. Okay, so we just showed one up there, one marginal distribution was listed there in the example above. That comes up more later, like I think in a later section we actually do more with that, like maybe 5 or chapter 5 or something like that. It comes up a lot more. So that's the end of the notes themselves. We're gonna go into the worksheet that I handed out to you. There's no way for me to really put it on the iPad and be able to write on it that I have figured out thus far. Oh, it's raining. That's unfortunate. Sorry. Squirrel. Anyways, so I might like throw it up under the screen and show you something on my copy or a couple things that I can't really do separate, but just so that it can be in the video, what I'll do is I'll write like what number or what bullet point we're dealing with, and then I'll go from there. If we were just in class like normal and everybody was here, like I probably would just put this under and just wouldn't record it. But since I'm trying to make sure that I can explain everything since some aren't here, that way we have it for today. So if it's confusing, let me know and I'll just pause and put it under there and we'll just go back and forth kind of. But anyways. Okay. So obviously your page is blank. So we're going to look at that first example there. 200 adults shopping at a supermarket were asked about the highest level of education they had completed and whether or not they smoked cigarettes. Results summarized in the table below. Okay, and I will tell you things that you'll notice that come up a lot are like drug use, smoking, sometimes like alcohol questions. I don't really know why, but the book for some reason seems obsessed with those topics. Just be aware that they're in there. I probably don't have to say this, but obviously we don't condone all of those things. It's purely for the purpose of an example, and they're coming from the book, so they're there. Anyways, just the plug for the whole year right there. So we've got, I'll go ahead and throw my copy up here for a minute, and I may have to turn this light on so y'all can see this a little better. You can ignore those percentages for the moment that I have written in. We'll actually find those. I'll just cover this up real quick. So this whole thing is a frequency table. Okay, it's got the totals listed. It's got everything given to you. Sometimes they don't total it for you and you have to total it yourself, so just be aware. The two things that I have the arrows drawn to, the smokers and the non-smokers, those two columns are conditional distributions. Okay, and then in the total column, those are marginal distributions, okay, that are given to you. Okay, so the first part of that question says to, I'm going to just try to leave the light on. If it gets to the point where y'all can't read something, just let me know and I'll flip the switch back off. So the first part of the question says to identify the variables in this problem. So this is kind of going back to chapter 2. Okay, so what are the categorical ones? Yeah, that's fine.
I have the highest level of education and whether or not it affects the rest.
Yep. So education level and whether or not a person is a smoker. And those can kind of be worded however. In other words, the way you said it was fine. All right, and then quantitative ones for that one.
The number of smokers, maybe? I don't know what else would be.
So sometimes with these, you have to look at the table that's given to you as well. So what is another factor that you see listed in that table?
Or I guess
Total number?
Number of what?
Smokers?
years of college or education.
Yeah, number of years in school. Okay, education level. So education level by number of years in school. Okay, and that's because that can be measured. It can be measured numerically, which is why. All right, so the next part of that question says to find each percent, and it wants to know what percent of shoppers were smokers with only a high school education. Okay, so things, if you have a highlighter, you might want to note here on this question some keywords that will help you, because the way that these are worded affects the answer. Okay, if this question was worded slightly differently, your answer is entirely different. Okay, so in this one, percent of shoppers, highlight that part. Okay, so you'd be highlighting percent of shoppers, highlight smokers, and then highlight high school education for that one. Okay, and then we'll look at that one and what that means. Okay, So this says what percent of shoppers, okay? That means that's the number that's going on the bottom. Okay, we're going to make a fraction bar, and that's the number that's going to go on the bottom. So it says what percent of shoppers, that's the total number of all the shoppers combined. So in this case, it's going to be 200. Okay, and then it says we're smokers with a high school education. Okay, so we're going to go to the smoker column. Okay, so we're going into the smoker column, and then we're going to go to high school education. So that's going to be 32 out of the total 200. And then you'll just divide that, tell me what the decimal is to 2 decimal places, and then give me the percent. So 0.16 or 16%.
You have to have both.
You really need the percent. I just usually put the decimal down as well, and then I just convert it. But no, you don't technically have to have both. All right, so then the next one, okay, what percent of shoppers with only a high school education were smokers? Okay, so highlight percent of shoppers with only high school education. Okay, so from the second word till almost all the way to the end. And then skip the word were and then highlight smokers. Okay, so with this one, we're looking at the percent of shoppers that only have a high school education. So what is that total?
93.
Okay, 93, so that's what's going to go on the bottom of this one. And then we're smokers.
32.
Okay, so 32 out of 93.
34.4%.
Okay, so 0.34 or 34%. All right, and then in the third one there, what percent of the smokers had only a high school education? So in this one, you're highlighting smokers or percent of smokers, and then high school education. So for this one, the total number of smokers is going on the bottom.
So 50.
So that one will be 50. And then on top, high school education. So 32 divided by 50. 64%. 0.64. So you see, those questions were all worded very similar, but their answers are all very different. Okay, the biggest part is reading and really understanding what it's asking for. Okay, it's not trying to trick you. Okay, I try not to pick the ones that are worded so weird that there's like absolutely no way you're gonna get it right. Okay, there are some that the book has that are worded, well, not so much the book, but I have like a test generator that like makes questions for you, and some of them are worded so weird it's hard to even know what it's asking for. So I try not to pick the super crazy ones. Okay. So then the next question there, do these data suggest that there is an association between smoking and education level? Give statistical evidence to support your conclusion. Okay. So, in a sense, we need to do some more percentages here to figure out if that's true or not. Okay? If there's an association between smoking and education level. So, we need to see the percentage of the whole entire group of people that are smokers. We need to know what that percentage is. We need to know the percentage of four-year colleges people that smoke. We need to know the percentage that have a two-year college that smoke, and the percentage of high school grads that smoke. Okay? So, with that, what percentage of the whole group is smokers? How would I set that one up?
Yeah, 50 over 200.
Okay, so the first part,
So we're supposed to put this in the writing part?
yeah. You have to write kind of small. I don't always give enough room to do everything, so just fair warning. So what percentage does that give us?
25.
Okay, so 25% of the whole group are smokers.
Then would you do, well, we already have a high school
Yeah, we already have the high schoolers that were smokers, so we don't need to show any work for that one. We can just say 34% of high school grads were smokers. Okay, and I'm just going to make a note to see above. Okay, you don't have to show that. If that's something that I know you've already worked, I'm not expecting you to show it again. Okay. So now we can kind of take, as we're thinking about the last two, we can kind of take that question that we did for each percent, and we can just fill in now 2-year college and 4-year college where high school grads was written in that question. So we can look back. What percent of the shoppers with only a 2-year college degree or 2-year college education were smokers? So we want to set it up the same way. So what was the total number of people with 2-year college? 22. And how many were smokers? 5. So what percentage does that one give us? 23%. Okay, 23%. Okay, so of 2-year college are smokers. And lastly, we need to do it for 4-year college. So what is that one going to look like? Plugging in 4-year college instead of high school in that same question.
You do 13 over 85.
13 over 85. And what percentage is that? 15? So that's a 4-year college are smokers. So, are those numbers all the same?
No.
So is it independent?
No.
No, not independent.
The high school grades are the ones that have the highest percent though.
Do what?
Those people with high school that smoke, like those are the highest percent of people.
Okay, so that is something that we are going to mention. We're really into class. Wow.
Is that really?
Yeah.
Okay.
Well, it's 138 instead of 139, but.
That's fine. Okay, well, we'll finish this question tomorrow.
Now we're by like